posted on Schoology. It's just the raw footage of me teaching. It's not that entertaining, but just in case if you ever need to. If you knew you were absent and it was a rerun of Price is Right, you'd already seen 3 times. You can go to that. All right. What questions? Yeah. 15. The 3x squared plus 5x minus 4. Okay. So let's see if we can figure that one out. So I'm going to go y, and realize I'm going to put y in there so I can get a graph. We are cheating, or we are understanding the system of factoring, but we're reverse engineering our graph. 15x minus 4. Okay, and let's make that a little darker. Ooh. Gosh, what fractions would those even be with? What do you think? This is negative 9/4, you think? We can see. So negative 9 divided by 4. It's close. It's close, right? Negative 9/4 is negative, but I have this 7 out there, so we're off a little bit. Okay, let's guess something else. I like the thought on it. Let's go maybe negative 7/3. Nope, that's off a little bit. So again, I'm trying to get to that value. I went the wrong way. 2 weeks, 2 days, no one's here. You know what I would do on this one? I probably won't give you one that's going to be this kind of ugliness. Honestly, I think this one, did anyone get it to factor a traditional way? So like maybe negative 12/5. No, that's still off. Just trying to think of. Yeah, you know what? I would skip this one. Because they're traditional. I would bet you, well, let's see, 12. Let's see, my first and last would give me negative 12. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Yeah, you know what? This one doesn't factor. This one's, we used to call it prime. Okay, if you do your traditional factoring. So Desmos will only take it out so many decimal places before it truncates it off, which is fine. But I don't think that one would factor. Cool. Any others I could help you? Yeah. 13. Okay, so number 13. This is how I'd like you to do number 13. Because we have both x and y in there, this is two-dimensional graphing, meaning it's not going to look as pretty on Desmos. So I have this. Okay, so what I think you should do on this one is I think you should break down 24 as far as you can go. And don't tell any of the other math teachers, but I'm using a factor tree because I'm that dude. So 2 and 12 gives me 24. Agreed? 2 doesn't break down any further. 12 breaks down to 2 and 6. Okay? 6 breaks down to 2 and 3. So that means 24 is 2 times 2 times 2 times 3. Do you see how I got that? And then x to the fourth is, and then y. So that's the first one broken down. Let's break the second one down. 2 goes into 30 15 times. 2 doesn't go into 15, but 3 does. So 2, 3, and 5 is how I'd break down 30. And then x squared is xx, y squared is yy. And then let's highlight what we have in common. I have a 2 in common and a 2 in common. Okay, I also have a 3 in common and I have a 3 in common. I have an X and an X, an X and an X, and that's it. And then I have a Y and a Y. So what I've highlighted between those terms that are completely broken down, that's completely broken down. What I have in common between the two is I have a 2, a 3, an X, and a Y. Okay, well, 2 times 3 is 6. X times X is X squared, and then Y, and then parentheses. And what do I have left? Well, 2 times 2 is 4. X times X, X squared, and then 5Y. And that's exactly how I'd factor it. And I kid you not, when I go to math conferences, which I know you realize I have an exciting life when I'm going to math conferences, but they have the icebreaker. This is how you should always open your class. Well, it doesn't work, but they always make us teachers do it, and it's like, whatever. But they'll give us something like this, and this is exactly how I'll do this problem. And I'll get someone at the table and go, why are you doing it that way? Because it works. Yeah, but you should see. You have a degree in math, you should. I'm like, dude, it doesn't matter what degrees I have. I have more degrees than the majority of the people in the building, including the presenter, but I'm still going to do it that way because you know what? This guy sees it that way. I got through math classes by realizing what breaking down things does for me. And I know it sounds funny, and I know a lot of people say that's like so middle school, but that's how I see it. And I kid you not, it's funny because people will sit there and give me a hard time, but it's like I'm not claiming to be the smartest person in the room, but I know how to do the problems because I can do it the middle school way. What other questions you come across on last night's homework? Did all the synthetic division ones, did they all happen to cross at really nice spots? Should we do one of them? Let's see, I did one of them, didn't I? I did 17, so why don't I take a look at 19? Sound okay? Okay, so number 19, I'm going to go right to Desmos first. Get rid of all this. And I'm going to go y equals 2x to the third. And we said that's a wiggle, right? But that doesn't mean that it's always going to be a wiggle. So that, oops. Bring that down. Plus 5x squared plus x minus 2. Cool. All right. So because this is raised to the third power, that means we could have 3 crossings of the x-axis, which is beautiful. So those are the 3 spots it crosses. So, and we know it crosses because the y value is 0. So at -2, what's the binomial that goes with -2? Should be x plus 2, right? And we'll just write that right here, x plus 2. And just ignore the graph that's taking place. Actually, we can turn that off. Turn that off. Turn off. Okay. And then going back to my... What should the binomial be at -1? X plus 1, okay. And then we have that last one here. 0.5 is the same as what fraction? 1/2. So let me just go back because I can't remember how to do everything. Okay, so 1/2. So 0.5 is equal to 1/2. So that means that x equals to 1/2. Multiply both sides by 2, agree? And then subtract 1. Right? So 2x minus 1 is the other binomial. I'm going to say 2x minus 1. Oops. Put a parenthesis. Put a parenthesis. Cool. And so if I graph this, if I just hit this, ready? Is it the same graph?
Yes.
Perfect. Does that make sense? And again, I have a lot different way that I present the algebra because I think Desmos is such a valuable tool for you. And again, you will have Desmos with you. If you were to take my prop stats class, which I know you, is anyone taking prop stats with Mr. Anderson? No? Okay. And none of you have me for prop stats. Sorry about that. But I use Desmos exclusively because, one, I want you to realize there are things that people will try and exploit to you. If you have a calculator, you can verify. You can either tell the person, I call BS, or you can walk away and say, that guy's an idiot. Okay? Any other questions off the homework, or we feel okay? Okay, can I go to the algebra review number 2? You with me on that one? So some things that you might see on that is now we're going to introduce the equal sign to our actual problem. Now the equal sign in traditional Algebra 1 classes or Algebra 2 classes would have been like this. So if I had say something like this, 7x squared equals x minus 3. And I know that's not a problem on your paper. I'm just trying to give you an example. If I had something like that, basically what you would probably do is you'd subtract x from both sides. Agree? You would add 3 to both sides. So you'd wind up with 7x squared minus x plus 3. And then you see if you could go by factoring or use the quadratic formula or anything like that. Agree? So first thing we have to realize, if I have an equal side, I have a left side to my problem, I have a right side to my problem. Does that make sense? Pretty simple to say something like that. Where do you think I'm going to go with this problem? I'm not manipulating a thing on here. Where do you think I should go? Desmos. Okay, if I go to Desmos, so I have a left side, so I'm going to go y equals, what did I say it was? 7x squared. So it's a parabola. Yay! Then I'm going to go to the other side. I'm going to go y equals, I have to go back and look at it, x minus 3. Okay. So friends, take a look at that. I have a parabola, which would have been in the left side. The 7x squared creates a parabola. Agree? The right side creates a straight line because the line y equals x minus 3 has a slope of 1 over 1, has a y-intercept of that. So question for you, my friends. Do those two graphs cross each other? Okay? So this automatically, without doing anything else, I mean, you could jump into the quadratic formula, and then you're going to get 7 plus or minus the square root of negative 8 all over 3. You're like, what's this negative square root negative 8? It's like, oh, that means I. What? I. Is that like the variable I? No, I is part of the imaginary number system, which is part of the complex number system, which is the larger number system than the whole number system or the natural number system. But that's a whole proof that you get to do in abstract algebra 5 years from now, if you choose to go get a degree in math. So right now, these two do not have a solution. Now, let me do one that does have a solution. Okay, so I'm going to just back up on this. And I'm going to go plus 5. Okay? So this does have a solution. This has two solutions, in fact. It has a solution here and it has a solution here. Okay? Now, the only thing I'm worried about, both solutions are given to you as a point. But all you need for an answer on this type of problem, if this was the problem I gave you, would be my answer is negative 0.777 and my answer is 0.92. Okay? So you only look at the x component as your answer. It's what's taking place in the x direction. Okay? Yes, you know what? I could graph this. So let me do this. Let me graph the two, but I'm going to leave this up here. I'm going to graph the two, putting it together. So on this problem, if I wanted to have 7x squared equals x plus 5, let's just say that was my problem. I could then have, see if you can follow me on this. Hang on. Y equals 7x squared. Okay. Now, if I had this and this equal to each other, I have to go subtract x. So this is going to become a minus x right here. Did you follow what I just did? And if this is a positive 5 here, what's it going to be on this equation? If this was a positive 5 here, and I set 7x squared equal to x plus 5, what would the plus 5 have to be if I had it in this equation? Minus 5. Okay, so a few things that are taking place I want you to realize. Take a look at my x value here and my x value here. Okay? Oops, I went to the wrong one. My original one was the blue one, wasn't it? The blue. Okay, so the blue and the green was my original. The purple was what happened. So negative 0.77 and 0.92 are the x values here and here. Agree? Does that make sense how I said that? And again, I'm not worried about the y value. But then if I look at this, if I take the x value here and the x value here, what do you notice about this x value and this x value compared to what's above it? They're the exact same. So kind of the big leap of faith that you're taking right now is this. Okay, if I graph a parabola and I go and solve the parabola for where it crosses the x-axis, that's going to give me an x value with a y value of 0 because the x-axis is 0. That's why down here it's negative 0.777 comma 0, and this is 0.92 comma 0. So this is the actual parabola that went with this system of equations. So what I want you to see is the x values maintain. So if I had done this, take that away, my original problem was this and this, the two x values are where it crosses the x-axis if I had put this back together to be this type of equation. So if I had 7x squared equals x plus 5, if I wanted to try and solve it, the x values for the solution to the problem is negative 0.777, which is 7/9, I think, and 0.92, which is 92 over 100, which reduces to, I'm not going to do that. But that's what takes place. So that's a kind of a eye-opening situation, is to realize when this takes place, those values are the same. And that's a big aha moment a lot of times for students, especially as you start progressing further and further into math, because there's going to get to points where you kind of get lost, so you get to survival mode. Survival mode means you're utilizing Desmos, you're utilizing the technology to try and get you to reassure you to understand the concept at hand. So for any of those problems down there, other than number 5, you can set each side equal to 0. Now, the reason why number 5, they want you to solve for y, so I would just, actually, let's just X off number 5 on that, not even worry about it. But all of the rest of those problems, if you graph the left side as one equation and you graph the right side as the other equation on Desmos, and you figure out where they cross each other, the x value of the points in which they cross would be your solution. Okay? And my friends, it's totally fine if you leave this as negative 0.777 and if you leave this as 0.92. I'm not worried about you converting it back to fractions. Okay? I was showing the fractions to show you on the factoring how it would work. Now, look down at the very bottom of the page. Okay? We have inequalities down there. Agree? Watch how nice an inequality would be to do here. Hey, can I get rid of this? Just go bye-bye. Okay, so if I had an inequality, you know, a lot of people will groan about it. Now, they want the intervals of what's going to take place. But what I'm going to do on this is I have something called critical values, which is where x would be equal to 0. So you have x minus 2, so where that 0 it happens at 2, because if I plug it 2 in, 2 minus 2 becomes 0. And at negative 3 as well, because if I plug negative 3 in for x, I get negative 3 plus 3, which is 0. But watch what Desmos will do that is so much more friendly. I'm going to go open parentheses. I'm looking at number, let's look at number 14. 3x plus 1, parenthesis, 2 minus x, parenthesis, And then look what Desmos has. Has inequality signs. Oh, this is the best day ever. So we want the less than 0. Okay. Why? First thing I want you to realize, why do I have these as dotted lines? It's totally correct, but why are they dotted? Let's see where you remember Algebra 1. Why would that be dotted, not solid?
It's not including those.
Yeah, it's just less than. So my inequality is just less than. I don't have the equal sign here. If I change that equal sign, if I change this to this, notice it becomes solid. Okay? So the inequality sign, the inequality is for a reason. All right, so now this shows us a two-dimensional graph where we have grays over here and we have grays over here. Okay? So what I'm going to do is I want to know these two values, this value here and this value here. Again, don't worry about converting a decimal back to a fraction. Keep it as a decimal. I'm totally fine with it. It's not a big deal. So this particular question is, we want to write the interval, okay? And we're talking about in the x direction. I'm not worried about what's going on in the y direction. The x direction, where this graph is going to be a value less than 0, meaning it would be negative. So if you think about negative as far as the xy axis, this is my x-axis right here. Everything below this is a negative number. What this basically means is if I plug from negative 10 all the way to negative 0.333 into this, I'm going to get an answer that is a negative answer. If I plug an answer from 2 all the way to 10, that's going to also give me a negative answer. But does this graph end just at negative 10? Or does this end at positive 10? So what's a number that goes really far to the left? The furthest to the left you can go. What is it called? Negative infinity. What's a number that's way to the right, as far as you can go to the right? Positive infinity. Do you remember that? So negative infinity is way over this way. Positive infinity is over this way. So if I wanted to get the solution to this problem, I'm going to say that this problem, 3x plus 1, 2, I can write better. 2 minus x is less than 0. Where is the interval that this takes place? Well, from negative infinity to negative 0.3333. Now, some of you might look at it saying, can I have negative 1/3? Yes, you can. Okay? And then from 2 to infinity. This interval right here, if I plug in any number from negative infinity all the way up to negative 0.333, and I plug in for x on both of my parts of my problem, I'm going to get a negative answer. If I plug an answer in that's bigger than 2, so if I plug in 2.1, it's going to give me a negative answer. Okay? And that's where we're going to start doing something. Some of you, I know, have taken pre-calc. Do you remember sign lines? You ever remember that? Where you put plus, minus, plus? And then sometimes you have the plus, plus, minus, minus. And you're like, what's going on there? This is where Desmos is going to make this a lot more clear and a lot more friendly. Because, yeah, I've taught sign lines for a long time. And it gets tough going, okay, I have plus, minus, plus. What's taking place between a plus, minus, plus? It's like, well, we have it crossing the x-axis. But with Desmos, it makes it friendlier. So this problem goes directly along with what that is. That's all it is, okay? Did I teach enough for you? Any questions? Let's watch your eyes. I'm getting brighter. I think they're done digging holes out in the hallway. That or he's going to bring the jackhammer in next. And you go, I'm sorry. Stirrup's mind goes all over the place. That's how I roll. All right. Let's give you the opportunity to, on this page, algebra review number 2. I think if you did 1 through 15 odd, and skip 5. I think that would be a good opportunity to show what you know. Sound like a plan? Yeah.